Hello students, in this video we are going to study about the postulates of Bohr's atomic model. As we have studied in Rutherford's model, that was failed to explain the discrete or the line spectra as well as the stability of atom. So Bohr in his model used two concepts. First is Rutherford's model and the second is Planck's quantum theory. Right? Bohr used these two concepts, merged these two concepts to give his atomic model, which can explain the spectra emitted by the atom as well as it can explain the stability of the atom also. So Bohr's atomic model is basically a modified version of Rutherford's model in which he used the results of Rutherford's model as well as add Planck's quantum theory in it so that the drawbacks of Rutherford's model can be sorted. So let's move to the postulates of Bohr's atomic model. This atomic model is also known as planetary model of atoms sometimes because it work like the electrons are moving around the nucleus just like planets move around the sun. So that's why we also call it as planetary model of atom. So let's see the postulates of Bohr atomic model. So the first postulate of Bohr's atomic model is based on the nuclear concept that was also present in Rutherford's model. Nuclear concept in which according to him an atom consists of a small and massive central core called nucleus and around which electrons revolve just like a planetary motion, and the centripetal force required is provided by the electrostatic attraction between electrons and nucleus, right? So nuclear concept that was given by Bohr is an atom consists of a small massive core at the center called nucleus and around which planetary electrons revolve. A required centripetal force for this planetary motion, required centripetal force is provided by electrostatic attraction between these electrons and nucleus. This was the first postulate of Bohr's atomic model. Second is about quantum condition. We also call it as quantization. Quantum condition. Then according to Bohr, he used Planck's theory and state that of all the possible circular orbits allowed by classical theory, electrons only permit to circulate in those orbits in which angular momentum of electron is integral multiple of h upon 2 pi, where h is the Planck's constant. So he used Planck's theory to explain this quantization condition or to explain the spectra, the discrete or the line spectra that we get during the practicals. So according to this quantum condition, we also call it as Bohr quantization condition, right? We also call it as Bohr's quantization condition. According to this, of all the possible orbits, electrons are allowed to move only in those circular orbits in which angular momentum represented by L, angular momentum of electron, is given as L is equal to nh upon 2 pi. That means angular momentum is equal to integral multiple of h upon 2 pi, where h is the Planck's constant and the factor h upon 2 pi sometimes also written as h cross. This is h cross. The meaning of h cross is h upon 2 pi. So it should be this angular momentum that is equal to mvr, it should be equals to nh upon 2 pi according to Bohr's quantization condition, and electron will revolve in those orbits only in which the electron has momentum, angular momentum L is equal to nh upon 2 pi, where n is equal to 1, 2, 3 and so on. That means integral multiple of h upon 2 pi, and this is called Bohr quantization condition, and the value n is called principal quantum number. N is called principal quantum number, right? Third condition is of stationary orbits. Third postulate given by Bohr is of stationary orbits, and by stationary orbits we mean that when electron revolve in a permissible orbit which has angular momentum equals to integral multiple of h upon 2 pi, that electron does not radiate any energy. It means these orbits are non-radiating and we call them as stationary orbits. So when electron is revolving in allowed orbits or permissible orbits, it doesn't radiate energy. That means these are non-radiating orbits and known as stationary orbits. So these stationary orbits are basically non-radiating orbits in which electron revolves but doesn't radiate any energy. This is the third postulate. Now the last one, the fourth postulate, is the frequency condition given by Bohr. So he said that an atom can emit or absorb a radiation in the form of discrete energy photons only when it jumps from higher to lower orbit or from lower to higher orbit respectively. So according to Bohr, it can be explained by example or by the diagram. Suppose we have two energy levels E1 and E2 such that E1 is less than E2. E2 is the higher energy level, E1 is the lower energy level. These are the stationary orbits in which electron can revolve. Now electron can absorb a photon. If there is an electron which is at E1, it can absorb a photon and jump to E2. Similarly, if there is an electron at E2, it can emit an electron and jump to E1. So according to Bohr, this transitions or emission or absorption of radiation is in the form of photons, which is discrete, not continuous. This emission and absorption of radiation is in the form of discrete energy photons when electrons jump from a higher to a lower orbit or from a lower to a higher orbit, where the frequency of this photon is actually given by the difference of these energy levels, because this is the energy required for the electron, or this is the energy given by the electron when it jumps down. When electron has to jump up, it need this much energy to go to the energy level E2. So there should be the photon of this much energy. That means h nu should be equal to E2 minus E1, and if that electron wants to jump to lower level, that means it will emit energy photon of this energy difference. So basically the thing is, an atom can emit or absorb, it can do both, it can emit or absorb electrons, photons, it can absorb photons, that means radiations, in the discrete energy form, and the frequency of those photons can be given by this frequency condition, that is h nu is equal to E2 minus E1. So these are the basic postulates of Bohr's atomic model, on which he explained the atomic model and sorted out all the drawbacks of Rutherford model also. So that's all for the video. For further videos, stay tuned and keep studying. Thank you.